In this video, we'll look at a few number-related manipulations making use of both division and modulus operations to, for example, find the length of an integer. Before we get started with coding, let's look at this. Assuming you have an integer I, which is equal to, for the sake of illustration, x, y, z. X, y, z each represents a digit, 0 through 9. Obviously, x is not going to be 0, but you get the idea. Let's look at the effect of taking x, y, z, which represent different digits, or maybe the same, divide by 10. If you do, with this divisions, you'll end up with xy in Java. If you do x, y, z modulus 10, you'll end up with z. Now, xy is also referred to as the quotient. Z is referred to as a remainder. Remember, using modulus gets you the remainder of that number when you mod it by 10. Basically, what you do is, if you were to take the outcome of xy and repeat the same thing, this is operation 1, operation 2, and in your operations 3, xy divided by 10, you end up with x. You use the same thing, xy modulus 10, you get y. And you can see the pattern. The very last operation, which is number 5, is you would take the outcome of xy further divided by 10, it'll give you a 0. X mod 10 is going to give you x. You can see the pattern, and that's it. The very first one is xy. The second one is x. I can also get z. So making use of this pattern, 1, 2, 3, 4, 5, there is a loop going on. You can extract every single digit inside this number. Let's just assume we don't have x, y, z, but 1, 2, 3, 4, 5. Try to use this approach to extract 1, 2, 3, 4, 5 individually out of your entire number. You can also use this approach to reverse this number to have it become 5, 4, 3, 2, 1, using the approach similar to this. Let's get to code. Let's try to find, for example, if we have 1, 2, 3, 4, 5, its length. The answer is 5 because there are 5 digits. How would you write that in Java? Making use of this pattern we just talked about. Let's take a look. I'm going off of this popular website called Programmist. This is an online Java compiler, and there's already a hello world here. Let's just say we have integer number 1, 2, 3, 4, 5. Our goal is to write logic to find out the number of digits. We're going to start off with a counter. This counter is going to be initialized to 0. Ultimately, this length should be 5. Let's see how we do it. We already know the number is positive, so there's no need to check for a negative number. So we can say, well, this number is greater than 0. Then we're going to repeat number equals number divided by 10. What I'm doing here is, with respect to 1, 2, 3, 4, 5, if we divide by 10, this will give us 1, 2, 3, 4. Notice that the very last digit is gone. Now, if I take 1, 2, 3, 4 and divide by 10, this is going to give me 1, 2, 3. Notice that the very last digit is gone. Now, if I take 1, 2, 3 and divide by 10, I get 1, 2. And notice the very last digit is gone. So this is how I'm able to remove last digit by way of using number equals number divided by 10. You can also shorthand this using a unary operator that we learned by writing this. Okay, let's check our logic. Now, while number is greater than 0, this is just going to keep going. And every time you do a division by 10 on the number, you're getting rid of 1 digit from it. So this is where we want to increase our length, because after each removal, you simply count the lost digits. At the end of your run, you should have the total number of digits removed, and that is the answer. So let's print this out and see what we got. Let's run it. All right, the answer is 5. There's a couple drawbacks. One is the number that you specify at the beginning is no longer going to be the same. If you wish to keep the integrity or the value of the number that you have in the input, then you can create a temporary number and simply just use that temporary number equals number as a starting point to get your counter. But in this case, there's no need for that, since you're starting with a primitive, and this primitive is not really an object for you to keep around. Since we add this, let's see if we can create a static method that returns an integer by counting its length, taking in the number input. So let's copy and paste this into your method, and we want to return our length at the end. What we can do is we can invoke its length function by passing in 1, 2, 3, 4, 5. and there is no need for this number. And before we run it, let's make sure this num corresponds to the name of the parameter. And also, we cannot run a non-static method from a static method. So let's set this to be static. Let's run it. As you can see, this is not a way of ascertaining the length of a number, the number of digits inside a number by invoking a static method. You can also move this whole thing out of here, and let's say for the sake of illustration, we create a public hello world. This is similar to what you have in the homework assignment from the standpoint of using a solution class. First, you define a class, and then you push this length into it. So this effectively become your solution method. What you can do here is you can instantiate a copy of your solution, and you can invoke this solutions method by way of using the reference object s dot length. And I want to do 1, 2, 3, 4, 5 as my input. And let's make sure we don't have more than we need. Let's run it. Again, this gives 5. This completes our demonstrations on ascertaining the number of digits inside a numeric input by refactoring a hello world static console application and making use of a solution method to achieve the same.